Hello, my name is Miles Curry, and I am a software engineer in M-Cubed and a developer on MPAS-Atmosphere. This lecture is divided into two parts. In part 1, we will detail how MPAS development is done, and we will give a brief overview into Git and GitHub. Part 2 will go over the techniques for debugging problems that you may have while trying to run the MPAS-Atmosphere model. As mentioned on the previous slide, in the first part we will go into how MPAS development is done using Git and GitHub. We will also give a brief overview of the fundamentals of Git and GitHub to help those who are not familiar with it. And in part 2, we will go over a few strategies you can use to debug your problems that you may have when running the MPAS-Atmosphere model. NCAR, alongside other major tech companies, is working on an initiative to remove non-inclusive language from its technologies. Thus, to be more inclusive in this talk, I will be referring to the master branch as the main branch. However, at this time of this recording, the main branch of MPAS is named master. As a software developer, Git and GitHub are some of the most important tools at my disposal. However, for non-software engineers, you may be wondering what's the deal with Git and GitHub and why should I have to care what it is? Well, even if you don't plan on doing any development on the model, there are a number of advantages to knowing how to use Git. First, when there's a new release comes out, you can easily update your code or code changes that you've been working on. Secondly, it allows you to see if you have altered the code in any way. This allows you to know if you're working on a stable release code or if the reason that the model is not compiling is because of that code that you added a few weeks ago. Thirdly, while you may not think that you want to do model development, you may develop code that you might want to use yourself later, but sometimes you don't want to use. For instance, you might add a few diagnostic variables which you may want to keep around as an example. Sometimes you want to run with these diagnostic variables, but other times you just want to run a stable MPAS version 7.0 release. Git and GitHub provide an easy way to store these changes. Along with that, more and more journals are requiring authors to publicly make available the code. Git and GitHub make an easy way to do that. As well, even if you're not publishing, you may want to share code with your colleagues. For me at least, Git and GitHub serve as a way to neatly keep track of different projects I work on, and allows me to easily switch between them with ease. And I can always go back to a stable release when I need one. First, what is Git? Git is an open source distributed version control system, or VCS. A VCS allows us to make modifications over time to a large software project, like MPAS, and keep track of those modifications. VCSs are essential for releasing new versions of the code, hence version control system, but also help with tracking down bugs. Git was developed by Linus Torvalds, who is the main contributor of the Linux operating system. There are a few ways to use Git, and since you'll be running the model on a Linux system via the command line, I highly recommend you get familiar with the command line version. It's honestly easier to use than the graphical version. There are two fundamental concepts to Git, and to any other VCS for that matter. The first is commits, and the second is branches. Now, I like words, so I provided the definition of these, just kind of for fun. Alright, on to commit. A commit is a snapshot of code at a particular time. Commits are identified by a hash, seen here, and normally have a message associated with describing them. A commit can be a parent of any number of commits, and these are called children. A child commit represents the changes between itself and its parents. So, for instance, the first commit can create a file named foo.txt, and the second commit can represent a user adding a line within that file. Furthermore, a child can also be a parent. Branches are quite simple, and they are just pointers to certain commits. In this case, the main branch points to the 51D56247 commit. As I mentioned, commits are on the left, and branches just point to commits. Now, to review the last slide, a commit is a snapshot of code and represents the changes made upon one or many files of a GitHub repository. Commits are uniquely identified by a hash. They're represented by this big, long hash number, but are normally just identified by the first 6 or 7 characters. A commit can be a parent of another commit, and in fact, a parent can have many children commits, which we'll get into in the next slide. and a branch is just a name pointer to a commit. Lastly, any commit can be checked out, and one can view the code as it was at that snapshot. Branches are fundamental to development. Here is the example Git history from the previous slides. In fact, the 51D5624 is the commit for the MPAS version 7.0 release. This chain of commits represents the modifications made to MPAS and go back to the very first one. As I said in the previous slide, a commit can have any number of child commits. So let's add a child and let's name it with the develop branch. And now let's add another branch and we'll call it Ocean Develop. As you can see, each branch starts from a stable release point, in this case the version 7.0 commit. Having multiple branches allows different teams to add commits to their own branches at their own pace. For instance, the Ocean developers can add to the Ocean Develop branch by checking out that branch and committing. This enables them to add branches that they control without the need for atmospheric groups to approve. Branches also offer a way to separate functionality. One can branch from the 7.0 release and add new features on the Develop branch. This ensures that the release is not touched. Now, to summarize the last slide. Branches allow for development to proceed from a stable release point without messing up the main release branch. This allows for a number of developers to contribute changes. And lastly, it enables developers to separate different functionality into different branches. But now you may be asking, how are branches merged back to the main release branch? Well, good question. Via a merge, of course. Here is an example of development on Git. Say the commit fd19a9 on the development branch is a stable release branch, and I, Miles, wants to add a new feature to it. I can make a new branch, say new feature using git branch new feature, and Git will make me a branch pointer that points to the fd19a9 commit. At this time, the branch develop and the new feature branches are equal. Now say I add a new commit, and you can see that my commit is added to the new feature branch instead of the develop branch, and the branch pointer is updated to the most recently made commit. Now let's say I add a few more commits, and then I'm ready to merge my changes back in. However, at the same time, Michael Dudot or another developer could add to the development branch by adding one commit or several more commits. And as you can see, our branches are now out of date. But that's okay. We can use a merge to put my branch back into the main one. Using a merge adds a merge commit and then puts a new feature branch onto the development branch. Now my new feature has been merged back onto develop. We merge branches into our development branch using GitHub's pull requests. GitHub PRs offer a convenient place for us to review, comment on, and test the code of another contributors. If you have code that you want to contribute, it's best to contact us via email and we can help you prepare your code for a PR. You may have noticed on the last slide, or on the GitHub repository, the Issues tab. One quick note about GitHub issues. The GitHub issue page is for issues with the code, i.e. bugs within the code, and not for issues one has with running the model. If you do have issues with running the model, it's best to go to the forum. If you think you have a bug, but you're not sure, it's still best to post to the forum. We can always elevate to a GitHub issue if it is in fact a bug. Now, before we proceed to the next part of this talk, I wanted to give some more information into Git and give you some resources to where you can find more information. You can use the manned Git pages, which are very helpful, but you can also use the online version of the manned pages at git-scm.com. As well as there's a book by Brent Straub, which is very, very helpful. As well, there's the atlassian.com/git/tutorials, which is a great source of Git examples and tutorials, and as well, Stack Overflow is always helpful. Now on to part 2. Even as a developer on MPAS, I still occasionally run into problems when running the model, so it's nice to keep a helpful phrase in mind. It's not if you fail, but when you fail. While I hope no one would make mistakes when running MPAS, it's going to happen. Here are some strategies that you can use to help yourself overcome problems when running the model. These are even strategies that we use when we run into problems. First, start small and build up from there. Don't try and run the 10-kilometer mesh before you even run a coarser mesh. It's best to get your simulation set up with a coarser mesh, See that it runs fine, and then try with a higher resolution mesh. If you're planning on running a complicated simulation, make sure you can do each part on its own separately, and then trying to put it all together. Don't try and run a high-resolution limited area simulation with SST updates if you have never ran a limited area region or done SST updates before. Try a limited area region first, then SSTs, and then put the two together. Take heed of what the model says. The log files may look like a bunch of gibberish, but they are quite important. Be sure to take note of them, especially the warning and error messages. It's quite common for users to pass over a warning message that indicates the reason for their problems. Likewise, normal output messages can be important as well, especially the global min and max W and U field. Do you see anything wrong with this log file from the atmosphere core? Yes, these win values are nonsensical. After this time step, the model crashed with no warning or error messages. However, if one examines the log file, they could find the cause of the crash. In this case, the config DT was much too high. If the model crashes due to a segmentation fault or a memory error, oftentimes no error or warning message is given. If this happens to you, first check to see that your simulation is not becoming unstable by checking the min and max values for the win fields. If it is stable, you might want to compile the model with debug equals true, which you can do as shown below. Doing so will hopefully generate a line number and will give you clues as to why your simulation is crashing. However, running the model with debug equals true causes the model to run very slowly. So be sure to clean the model and recompile it with debug turned off once you fix your problem. This is probably the tip that helps us the most when we run into problems, and is also quite useful for life in general. If you find yourself banging your head against a problem for a few straight hours, take a break, walk away, get some fresh air for a few hours or even a few days. Oftentimes, a fresh set of eyes will allow you to see something you missed in your frustration. Avoid getting tunnel vision. Take a break, walk around, take care of yourself, and return back to the problem when you're fresh. Likewise, it's nice to have a colleague who is familiar with MPAS to look over your simulation. Sometimes they can spot things in your files that you missed. Also, be sure to go over your namelist and streams files and ensure that things are set correctly. It is oftentimes easy to miss an erroneous nameless setting or a file in your streams. config.dt and config lendisp are often two nameless options that are forgotten about. Be sure that they are set correctly and match the grid that you are using. Lastly, we are happy to provide help and support for MPAS problems that you may have on our support form, but we have a few tips for posting there. First, try the steps that I have just outlined in this lecture, as we'll ask you to do them if you already have it. As well, search for your problem on the forum. You may find that your problem has already been answered. Second, take the time to come up with a good title and a good description of your problem, and what you have already tried to remedy it. When writing out your problem, you may think of something that you haven't tried, and it may help you fix your problem. Please do not just post a copy of your error message in the subject and in the description. It is really best for you and for us if you detail the problems that you are having and what you've already tried. And please attach all relevant files, including your namelist, streams file, and relevant log files. It's best to attach the standard 0001 log file, as well as a single error log file. If there are many error log files, please just attach one. And lastly, please just attach text files and not screenshots. Thank you.